Okay, this third one is exponential, not log. And the reason this one is showing up on the tricky day is because both sides have a variable stuck in the exponent and they do not have the same base. Not only do they have the same base, there isn't a base that will easily wipe out both of them. So you just have to try and choose the most efficient way to go about this. And I would say your most efficient way is to cancel out one or the other. Can't be both, but you can cancel out one of them. So I'm going to go ahead and choose, I don't know if it matters, we'll choose a log base 3. So I take the log base 3 of both sides. And there isn't a wrong choice here. Log base 4 will also make your life fairly easy. A natural log would work just as well here. It'll just be slightly messier. So I think it's a good choice to use 3 or 4, but any log will work. The left-hand side works out really nicely. Log base 3 of 3 to the x plus 1 is just an x plus 1. The right-hand side isn't as nice, but we still make some progress. Even though the log base 3 doesn't cancel out the exponential base 4, we do have the power property that allows us to drop that down to the front. So 3 minus 2x times the log base 3 of 4. The parentheses are really important here. Basically having all of that up in the exponent grouped it together, and when we move it down to the front, the 3 has to get multiplied by the log as well as the negative 2x. That was all power, so it should all be part of this product. And that's actually the next thing I need to deal with. Those parentheses are trouble. I'm trying to solve for x. I've successfully gotten all of the x's out of the exponent, but now I have one stuck in parentheses. I would not choose to divide here because that will stick an x in a fraction, which would be something that I'd want to deal with just as much as having x stuck in a parenthesis. So distribute. Looks a little messy, but the log base 3 of 4 is just a number that you're multiplying a difference by. So you can distribute it through and say I have 3 times log base 3 of 4 minus 2x times log base 3 of 4. I'm trying to solve for x. Sorry for the wiggle. So I think the next thing I need to do here is get x's on one side. And it doesn't really matter which side. I'm going to choose to move x's to the left so that I have fewer negative signs floating around. As soon as I choose to do that, I also will move the 1 to the right. So basically any term with an x gets moved to the left, any term without an x gets moved to the right. So this is headed that way, and this is headed that way. Okay, so I'm adding, leave the x where it is, add a 2x log base 3 of 4. This will eliminate the negative 2x log base 3 of 4 on the right, and instead you'll have one on the left. I'm going to leave the 3 times log base 3 of 4 on the right. I'm going to subtract 1, which will eliminate it from the left, move it to the right. Once again, make sure you don't try and subtract the 1 from the 4. Not good order of operations there. You'd have to take the log and multiply before you could do any subtraction. This is a step that a lot of people will get stuck on. I got x on one side, but there are 2 of them, and I can't combine a 1x with a 2 log base 3 of 4 times x. However, this is kind of like literal equations. There is another trick you can use, and that trick is factoring. So really make a note of this. Make sure that you don't forget that when you're solving these and you get the messy coefficients involving logs, the way to isolate a single x is to factor it out and then divide. And this is a completely acceptable answer. There are things you could play around with. You could move the 3 up, you could move the 2 up. I don't care if you do any of those. If you can give me an exact answer, x is all by itself, I will be happy. So try to deal with things like fractions and fractions, but I have no problem getting a log in an answer like this. I do not want you on any step along the way here to switch to decimals. I want that exact answer.